I have asked you to use two different methods. Please remind me of the three methods you have at your disposal. What is method one? Graph, and then you solve by inspection, right? Because all you have to do with a graph is look at it. Where is that graphed parabola greater than 0? The red parts or the blue part? The red parts. So, of course, it would be x is greater than there and x is less than there. If I did that, right? What if I did this? Now what would that sign be? There would be an equal to with it. Yeah? Where is that less than 0? The blue. Right now they're colored in, so it would be negative x. That should be in blue. Negative x, and since it's colored in, less than or equal to, and then less than or equal to the positive x. Yeah? Does everybody understand how to use a graph or how to read a graph to find the answers to a quadratic inequality if you have the graph? Everybody? You can all inspect a graph and understand that greater means above and less than means below? Yeah? Okay. Method 2 was roots and test points. Because the x-axis is split by most parabolas into how many parts? 3. Some parabolas split it only into 2 parts. Is it possible that a parabola will not split it at all? Yes. But there will always be, well, not always, you'll have a root and another root, possibly. And again, then you would just choose test points. Point A, point B, and point C from that region. Then you put them into the equation, you see which one works. And lastly, there's the one I do not like very much. There is case analysis, which is, of course, the one I'm going to spend the most time with on this section right now, even though we're going to do all 3. Everybody cool? We're going to rocket through the first 2 because they're pretty easy to work with. And then we're going to take our time with the third one. Of course, unless I specifically instruct you, do you ever have to use case analysis? No. So let us go. What can we do to graph that bad boy right now? Before I even graph it, there's something you can all see. What is it? Preston? You could take out the negative, which is going to give us what? No, I've taken out the negative. And that negative is in the A spot, isn't it? Which means this is what type of parabola? Sad, right? So, it's easy to graph because this parabola happens to do what? Factor to what? X minus 5 and x plus 2. Yes? Right? So what are my roots? Positive 5 and negative 2. And it's a sad parabola. Does it matter what the vertex is? No, because we only have one variable. So we only need x values, don't we? So all we need to care about is the vertex is somewhere in the middle, and it goes like that, yeah? Where is that? What sign is that one? less than. Where is this parabola less than 0? Is it the yellow or the blue? The blue. Where does the blue region begin? On the right. 5. Where does it begin on the left? -2. So just from looking at that, we know x must be greater than what? 5. Or x must be less than -2. And we know our answer just by looking. You must stop me now if you cannot understand what we have just done. Does everybody get it? Now, I know when I ask that puts you on the spot. And if you don't get it, you don't want to say because you don't want to appear like you don't know what you're doing. But I will submit this to you. Is it better to appear right now like you don't know what you're doing and ask for clarification, or is it better to hand me in a test that is done wrong? Which one actually hurts you? The second one. Which one doesn't actually hurt you but feels like it hurts you? The first one. Should that be an issue? No. Because how many times have you wanted to ask a question, not asked it, and then had somebody else ask that exact question 2 minutes later? A lot. Which means right now, if you don't get it, there's a pretty good chance somebody else in the room doesn't get it either. And they are sitting there going, I hope someone asks, I hope someone asks, I hope someone asks, because I don't want to ask, I hope someone asks, I don't want to ask, I hope someone asks. And then you don't ask, and now you've let down you and that person. So be a hero. Throw yourself on the grenade. Be a We Day candidate. Think of your fellow classmate. Are any of you bothered by the graphing way to do this? Even if it's you forget how to graph a parabola and I have to remind you from last unit. We're all okay? Now he's made such a big deal out of it, I would never say anything anyway. Okay. Let's move on to number 2, which is roots and test points. There is the x-axis. Right? What are parts of the x-axis are the important pieces of the x-axis right now? What are they? -2 and +5, which has broken the x-axis into 3 parts, yes? Which means I must check how many test points? 3. I need to choose a test point. Not as essential right now because the y values don't matter. I hear what you're saying, but because we only have one variable, we are going to dot it next lesson. But right now, it's more important that we understand that because there's only one variable, only the x's matter. Because no matter what we have for a y value, as long as x is bigger than 5, y is always going to be negative. And we only care about being less than 0. We don't care about being less than y. Understand? If we cared about being less than y, then we would have to worry. Cool? Okay. So here is my x-axis split up, which means I need a test point in there. What is an easy test point to use that is below -2? You could use -3. That would be easy. You could use -5. You could use -10. It does not matter. Whatever you are comfortable with. So since Priya started us off with -3, we'll use -3. What is the easiest test point to use in the middle here? 0. What is an easy test point to use out here? 6. Okay. So -3 is our first one. We've got it. Can I sub -3 into there? Can I sub -3 into there? Can I sub -3 into there? Oops. Which of those 3 do you feel is the easiest one to mentally check -3? Yellow, blue, or green? Which one do you feel? There's no wrong answer here. So somebody say a color. Yellow is what you would like to use? No problem. Anybody, if I did yellow, I would get an answer. Does anybody feel differently? Green? Would I get an answer? Could I use blue? Sure I could. Would I get an answer? And if I did my algebra correctly, I would get the same answer every time, wouldn't I? Now, I submit that I would use the green one because -3 minus 5 is what? -8. -3 plus 2 is what? -1. What is -8 times -1? +8. There's a negative out in front, so this side is -8, yes? Is -8 less than 0? Yes. So -3 is okay, which means this entire part of the x-axis is okay. Now, do I really need to check all three now? No, because I know how a parabola works. I know it goes up and comes back down. So I know that really the only other place I need to check is over here, right? But it's easy enough to check. Negative times a positive is a negative. Negative times a negative is a positive, which is going to be greater than 0, right? Come over here and check with 6. What's 6 minus 5? 1. What's 6 plus 2? 1 times 8 is 8. With a negative out in front is -8. Is -8 less than 0? So if 6 works, that means everything up here works. And then you just do the grade 9 thing. Since it's that, you circle it, you do not color it in. X must be less than -2, or X must be greater than 5. Now there's a fancy schmancy way to write that out. X such that X is less than -2, or there's a symbol for or. I don't care. Nobody will care until much later. What they will care about is you understand the concept. Okay? Now, since we are just dealing with numbers, is it every single number, including all the decimals and the fractions? Yeah, because it's just numbers. So eventually you're going to have that X within the funky E and an R as well. None of that matters. Nomenclature is not important right now. Concept is important. Is everybody cool? Yeah? Okay. Now, let us very carefully, and I'm going to rewrite it so it's not on this, so it doesn't leave the screen. -x minus 5 and x plus 2 has to be less than 0. Let's take a moment. Whoa, slow your roll there, big guy. Let's look at the case analysis here, because this is the one that causes everybody trouble. I'm going to write it out in 2 different colors. We're going to work with them in 2 different colors, yes? For this to be true, one of these has to be what? Negative. Now this bothers us, yes? Because then we have negative, right? So could we write this? -x plus 5 and x plus 2. Is that the same thing? Is it? Yeah, so we could do that if we want to. We don't have to, but we could, right? Everybody's good? So, for this to be true now, less than 0, this would have to be what? This factor would have to be what? Negative. If that factor is negative, then what would this factor have to be? Positive. What is the other option? This factor is, and this factor is. Everybody cool? Everybody's cool to there, right? Okay. Now that means, if we're doing the red one, it would be this. -x plus 5 would have to be less than 0, yes? Everyone agrees? And x plus 2 would have to be greater than 0. Everybody's cool there, right? So tell me what my x values are there. You do that while I set up the other one, which is, of course, just the reverse. What are my options over here? Negative x must be less than negative 5, right? Then to get rid of that negative, I divide everything by negative 1. X, what happens to the sign? It flips. X must be greater than 5. Are we happy? Everybody's cool? That's grade 9 stuff. We're all good, yeah? Okay, and then of course the other one, x must be greater than negative 2, and then we're done, right? Everyone's cool? So now, I get my number line, and I need 2 number lines, right? Because I'm checking both of these, yeah? The first one, negative 2, it's right there, yeah? And I got to be on that side of it. Because x is first, so I can follow the line, right? Everybody okay? And the other option is right here, 5. Yeah? Everybody cool? Where are they both okay? Are they both okay in this yellow section? No. So if we do this case, I am only allowed to have x is greater than 5, right? Because that is where they start both being true. Cool? Now let's go to the green side. Negative x plus 5 is greater than 0. Negative x is greater than negative 5. X is greater than positive 5. We still okay? I brought the 5 over. It became negative. Oh, I forgot to flip it. Right? We still good? And the other one is, of course, x is less than negative 2, right? So in green, x is less than 5, right? And x is less than negative 2, right? So where is the only place in the green line where they're both true? Out here. Right? So because the only place that they're all true is out here, I must be x is greater than 5 and x is less than negative 2. And my pen is possibly dying. Everybody okay? Concept-wise, again, if you can even do it once, you're good. We all okay? I don't like it, but I got to show it to you. We all good? All right. Can we turn the page? Okay. What's different? Manru. It doesn't equal 0, or it's not less than or greater than 0, is it? Damn. That's a pain. Or is it? Still one variable, yeah? Right? So, what would we do with this to make it look like something we want to work with? Manru. Move the 12. What's going to happen to it? So, this would become 2x squared minus 7x minus 12. What then? Is greater than 0. Everybody cool? So now what's our next step? 3 choices. What are our choices? We could do what? We could graph. To graph it, we would need what? Since it's only in one variable, what's the only thing we really need? We only need x values. And x values when we're dealing with the parabola are the roots, right? So all I need is the roots. What are my 2 ways of finding roots? Factor and what's the other way we can find roots? Quadratic formula. Does that factor? I cannot think of any factors of negative 24 that add to negative 7. So does it factor? So, even though it's different from what we've already done, we do have an ability to solve this, yes? So we're just going to get a different mathematical tool. And that tool we're going to get is the quadratic formula, yes? So how would we run that through the quadratic formula? What is A? What is B? -7. What is C? And then we just run it through. Most of you probably have it memorized, but maybe you don't. -b plus or minus the root b squared minus 2a minus 4ac over 2a. So, what are we writing? 7 plus or minus root what? 49 minus 4 times 2 times -12 over 2 times 2, which is 4, right? Get out your calculator. Tell me what that is. 7 plus or minus the root of what? Pardon me? 145 over 4. Can we stop there? Last unit, could we stop there, or do I want that simplified if possible? I want it simplified if possible, but do I need it simplified now? I only need the values of the roots, don't I? So I could punch this into my calculator. I can go 7 plus the root of 145 over 4, or 7 minus the root of 145 over 4. Agreed? Now you're intelligent young people. What perfect square is that very close to? 12. Well, that's the square root. It's very close to 144, yes? So since all that matters is I have the roots, I can estimate here, can't I? What is 7 plus 12? I'll get it! You guys solve that. Go for Myers. Oh, hello. Yeah, how are you? I'm very well, thank you. No problem. That's easy. No problem at all. Just give me one moment. Okay, ladies and gentlemen, find those roots, make the graph, solve it. Sorry, we're back. He's doing just fine. He had some trouble at the beginning of the semester, keeping his hands off his seatmates and buckling around. But he's sorted that out. Much of his test scores are not great, but when he had a chance to do a retest, he improved. So he's taking it seriously. His homework, I would say, is around 3/4 to 2/3 of he's done. He's not doing all the practicing. He has homework almost, well, I shouldn't say his homework. He has work that he did not get finished in class almost every day. So if he says he's got nothing to do for math, most of the time he does. What he will tell you is, well, I don't have to do all of it. And what he means by that is I give them work to do, and if they feel they are getting it, they don't need to do all of it, because I don't believe if you can do it 10 times, you need to do it. The problem is they only try to do it 10 times, get it right 2 times, and then they get it done, and then they get to a test then. So that is something he needs to work on. Yeah. Well, I've noticed results as well. So you've been pushing it at home. He is certainly less deer in the headlights. He actually has some things to say and is contributing. So there has been some reward for your efforts. Yeah. say if you were doing so. Options are, what's 7 plus 12? 19. 19 divided by 4 is really close to what? 5. Right? 7 minus 12? Negative 5 divided by 4 is pretty close to negative 1. Right? So I know that if I were to graph this, I'd be pretty close to 5 and pretty close to negative 1. Yeah? And I care about greater than 0, yes? So where is it? Oh, it's happy, sorry. Greater than 0. So where is it? Well, more than that root, right? And less than that root. Everybody understand? So I could write x is greater than 7 plus root 145 over 4. And x is less than 7 minus root 145 over 4. If I wanted it exact. Or if it was a real life situation, I'd give those decimals. Everybody cool? Ease, peas, lemon squeezy, yeah? Yeah? Yeah. Okay. Now, if I wanted to do it with roots and test points, I know I've got negative 1 and 5 approximately, yeah? Right? So, to do the test point, 0. Easy one, yeah. Here, I don't want to use anything close to here because I know it's not exactly 1. So what if I went all the way down to negative 5 and here I went all the way up to positive 10? Could I do it? Then I would know. And of course, if you did that, you'd have it. Now, case analysis is not a very good one here. Why? Why is case analysis bad for here? Do you get this nice split? Not really, do you? But you could if you wanted to. I, of course, wouldn't even bother because I already know the answer, yes? Everybody cool? All right. So you try 143. Okay, I'm going to pause it. Is everybody good? Everybody understands what I did here? I just made that 16, yeah? 2 plus 4, 2 minus 4. So I could get approximate answers. So I could sketch my graph. Because I only need to sketch it. McKenna. Yep. If it's greater than, then that's part of the solution, so we color it in. Do you want to actually see that? Okay, so I look back at the original equation, which was x squared minus 4x was greater than 10, yeah? So negative 5. Negative 5 squared is 25. Minus 4 times minus 5 is positive 20, greater than 10. 45 greater than 10. Good. Erase. 10 squared, 100. Minus 40, greater than 10. 60 greater than 10. Good. 0 minus 0 is not greater than 10. 0 is less than 10, so it had to be dead. Is everybody good? Yeah? Okay. You've got 35 minutes or something. Oh, we haven't done the key ideas. Let's get this together. What is the same with quadratics that was the same with linear inequalities? Where do the solutions lie? Pardon me? In this case, because it's one variable on the x-axis, right? And if it was a one variable linear equality, it's on the x-axis, right? Is it a value or is it a set of values? What is the answer to these questions? It's a set of values. So the solution is still a set of values. With a linear inequality, x is greater than 3, there's only one root, yes? But if it's a quadratic inequality, x squared is greater than or equal to 9, then I've got 3 and I've got -3. But they're still sets. Is everybody cool? That's the first key point. The solution is a portion of the x-axis, not one spot on it. Everybody's good? Next one, 2. There's 3 strategies. Strategy A is graph. But when I say graph, do I really mean graph it? Or do I just mean I need a general idea? It's just a sketch. Is it A or -A? If it's A, what does the graph look like? That. If it's that, what's it look like? Negative. And of course, there's a line there, right? Where is the greater than 0? Greater than 0, less than 0. Greater than's are yellow, less than's are blue. Where's the yellow line going? Is it on the horns or the smile of the first guy? The horns. Is it on the horns or the smile of the second guy? Or the frown? The frown. It's on the smile there, and it's on those lines that old people get right here. Mine are coming. You don't need to mock me about it. Down there. We all get that, yes? Right? So that's one. You sketch the graph. What's the second choice? Roots and test points. x1, x2. A, B, C. What do? Sub A, B, and C back in. And not so. And C, that's handwritten. Nobody can read cursive. And C, which satisfy the inequality. And C, what's our last choice? Case analysis. And analysis. And that really only works when we can factor. If it's factorable, it's a good one to try. And that's when it's x plus A, x plus B, greater than 0. Then x plus A has to be greater than 0. x plus b has to be greater than 0. Or, what would be the reverse that would keep this true? X plus a is less than 0, and x plus b would also have to be less than 0, because two negatives would make me a positive, right? Yeah? And the last key point to remember, 1, 2, 3. If f of x is greater than 0, do the roots count? Yes or no question. Do the roots count if that's the sign? I'm just going to keep looking at you, man. If I look at you long enough, you're going to flip-flop back and forth. Choose one and stick with it. And then tell me why. You're sure? Because you said yes before, and I just stared at you. I didn't give you any, and now you've said no. I'm going to keep staring at you. You're going to change it back to yes? You do know the answer, though. X is greater than 3. Does 3 count? No. So, when the whole function is greater than 0, does the root count? No. So when we graph it on the number line, it gets what? An open dot. What if it's that one? Roots do count. So it's a closed dot. Now remember, in linear, that's super easy, right? Because it only crosses the x-axis once. But on a parabola, you have to be aware, right? In a parabola, you have to be aware about the horns or the mouth. I'm out of ways to explain it, right? If it's that one and it's greater, I've got two sets, don't I? Right? This is for a greater than. It's going to be that and that. If it's a greater than, these are circles. There's two of them. If it's a less than, then it's in the blue. And if it's a sad parabola, of course, that's reversed. If it's greater than, it's there. It's going to be x. Oh, wait. I don't want to say x. It's going to be number less than x less than number for greater than. For less than, what's it going to be? Number less than x or x. Sorry. X is less than number or x is greater than number. If it's less than. Everybody cool? Everybody's good? All right. So I got 10:27. You're here till almost 11. That's half an hour to work on page 145 and 146. You'll notice I've left you a lot of blank space and the answers on each page. So you don't have to be flipping around back and forth. Hookley dokley? Hookley dokley.